Hi everyone, I am Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science. In this case study analysis video, we are going to discuss about the case study on binomial distribution. So before that, what is binomial distribution? Binomial distribution is nothing. If there are n trials, in these n trials, the x cases are success. In this success, how many failure? Out of n trials, x cases success, the remaining all are failure. So it is n minus x. These all are failure. Okay, so how define binomial distribution? The binomial distribution function is probability of x is equal to small x is ncx. Out of n trials, there are x possibility successes. Therefore, it is ncx. P is success. So totally x success. In finally we have p power x success cases, and q is failure. Here we have n minus x failure. So totally q power n minus x failure. So what is x? X is start from 0, 1, 2, etc. Why it is 0? The success. Suppose if it is no success, then it is 0. So therefore we start x from 0, 1, 2, 3, etc. So these are all the binomial distributions. Now we are going to the case analysis. So the case study is a box contains 100 transistors. Out of this 100, 20 are defective. So 10 are taken for inspections. So we calculate what is, or we find what is the probability for all the 10 transistors are defective. And second case is all 10 transistors are good. And third one is at least one transistor is defective. Okay, so how calculate? Before that, in these binomial distributions, we need what is x value, p value, and q value. So how we calculate x? Anybody?
Study explains about transistors, and the given probabilities are all 10 are defective, all 10 are good, and at least one is defective. So let's assign x be the number of defective transistors.
X be the number of defective transistors. So let us stay here. Let x be the number of defective transistor. Okay, so we have x is number of defective transistors. Now, when we derive binomial distributions, we need what is p and q value. So how we calculate p, or what is p?
P means possibilities. Here 20 defective transistor out of 100. So P equal to 20 divided by 100. So equal to 1 by 5.
The P is total number of transistor or 100. So we take 20 or defective. Therefore, the possibility for defective is 20 by 100. So P value is 20 by 100. So P is equal to 20 out of 100. That is equal to 1 by 5. Still we need Q value. So how calculate Q? Is anybody?
So P plus Q is equal to 1. So P is possible and Q is impossible. So Q is equal to 1 minus P. P we already have 1, we've already have 1 by 5. So 1 minus 1 by 5, the answer is 4 by 5.
So as per this, we calculate Q value, that is P plus Q is equal to 1. Therefore, Q is 1 minus P. Here we have P value, it is 1 minus 1 by 5, that is equal to 4 by 5. That is Q. So P is 1 by 5 and Q is 4 by 5. So now we go to the case analysis. Find the probability that all the 10 transistors are defective. So how write this? All the 10 transistors are defective. Yes, anybody?
Sir, as per the question, by the first illustration, as the 10 are defective, so P of x value is 10.
Questions? Probability of x is equal to 10. So why it is probability of x is equal to 10? Because x be the number of defective transistors. So we calculate all the 10, probability for all the 10 transistors are defective. Therefore, we can write this probability of x is equal to 10. So substitute the binomial form. N is 10, C, x is also 10, P is 1 by 5, the whole power x, P power x is also 10, and the Q power n minus x, Q is 1 by 5, N is 10, x is also 10. Therefore, 10 C 10 value is 1. 1 by 5 whole power 10. It can be written as 1 by 5 power 10. and 4 by 5 power 10 minus 10 is 0. Anything power 0 is always 1. Therefore, here we have 1 divided by 5 power 10. So that is for all the 10 transistors are defective. Next, we go to the second questions. Find the probability that all the 10 transistors are good. So probability for all are good. All the transistors are good. That is equal to 1 minus all are defective. 1 minus probability for all are defective. That is 1 minus, already we found the possibility for all the 10 transistors are defective. That is 1 minus 5 power 10. So it is answer for the second one. And third, what is the probability for second one? What is the probability for all the at least one transistor is defective? That is probability for x is greater than or equal to 1. So why we write probability of x is greater than or equal to 1? At least means minimum 1, maximum 10 transistor allowed. Therefore, we found probability of x is greater than or equal to 1. It's same as probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3 up to probability of x is equal to 10. It is a vast calculation. Avoid that. Probability of possible is 1 minus probability of impossible, or probability of impossible is 1 minus probability of possible. But it is possible. 1 minus probability of x is strictly less than 1. Because if it is greater than or equal to, therefore we avoid equal to symbol. Instead of greater than, we write less than. So 1 minus probability of x is less than 1. So that becomes 1 minus probability of x is less than 1 means there is 0 defective. Okay, 0 defective. That is equal to 1 minus, what is 0 defective? Already here we have all are good. It is a possibility. So we write again n is 10. NCX, x is 0, p power 1 by 5 the whole power n. N is p power x is 0, q power n minus x. 4 by 5 power n is 10, x is 0. So that is equal to 1 minus 10 is 0 value is 1, 1 by 5 whole power 0 is 1. So remaining we have only 4 by 5 the whole power 10. So that is answer for all or at least one is defective. That's all. Thank you.